The St. Louis Arch, this spectacular structure overlooking the famed Mississippi River in the city of St. Louis, Missouri, is one of the most innovative arches and recognizable icons in the world. Since 1967, when the arch was first built, more than 65 million people from around the world have come to visit. And for those who have seen it, the impression is lasting. The St. Louis Arch, known officially as the Gateway Arch, is America's tallest national monument and the only one commemorating America's westward expansion.
And the arch itself is like a piece of outdoor sculpture, if you will. It's a gigantic and very much a symbolic memorial to westward expansion because it takes the form of a literal gateway. It's a portal through which people could literally pass if they wished.
It stands 630 feet tall, 25 feet taller than the Washington Monument, and more than twice as high as the Statue of Liberty. One side of the arch faces due east, the other west, so that its polished stainless steel exterior reflects both the rising and setting sun.
I don't think there's been any 2 days that I've gone down there that it's looked exactly the same. The morning and evening light, when it's pink and the way it shines off of it, just gives these incredible colors that it reflects back.
It's a remarkable thing, I think, and it looks different from every angle. When you're up close to it, you can appreciate the incredible precision of the surfaces. It's really something to just stand and look at it for long periods of time.
Deceptively simple in appearance, the Gateway Arch is the result of exceptional design. It is not a traditional Roman arch, but something entirely different, an inverted catenary curve.
An inverted catenary curve is the form that's made by a chain that's hung from 2 points and then let to drop. So the form of the arch just reverses that. It's kind of like a mirror image of that form.
The arch's 630-foot height is identically matched by its width. It is also hollow, ingeniously supported by its outer core, like a stalk of bamboo.
The arch is composed really of 2 skins. The outer skin was made of the stainless steel on a steel plate, and the inner skin was made with carbon steel. And then the lower third of the arch is filled with concrete, and the upper 2/3 of the arch remain unfilled as a double skin.
At the base of the arch, the walls are 3 feet thick. They gradually taper to a mere 7 inches.
Most people just kind of look at that outside and don't think of the fact that there's a unique stair system that's on the inside that goes all the way to the top on both sides, that there's the whole tram system that's built in there with tracks and everything else that had to go in.
Each year, nearly 1 million visitors take the trip inside to the top of the arch in a unique 80-passenger tram that is part elevator and part Ferris wheel. There are 2 trams, one in each leg, operating independently. For emergencies, there are also stairs, a flight of 1,076 steps. The observation room at the top can comfortably hold about 100 people. It measures 6 feet 9 inches high and 65 feet wide. 16 small windows line the east and west walls to provide visitors with expansive views. To the west, the metropolis of St. Louis. To the east, the Mississippi River and the state of Illinois. In good weather, visibility is 30 miles. The arch was built to withstand winds of 150 miles per hour. It is also impervious to lightning strikes due to 7 lightning rods, each a foot high affixed to its top. What lies beneath the arch is a vast subterranean visitors complex with 2 large movie theaters and what's billed as the first underground museum in the United States. The arch itself is the centerpiece of the National Park Service's 100-acre Jefferson National Expansion Memorial. It is here on these very grounds where the village of St. Louis was founded in 1764 as a fur trading post and where pivotal moments in America's history occurred. Two major rivers, the Mississippi River and the nearby Missouri River several miles west, made St. Louis a perfect way station for hunters and traders.
Well, St. Louis, of course, has always been, probably since Native American times, a place of important juncture of rivers. And before there were railroads, that was the only way to travel long distances. So it was selected as the starting point for the Lewis and Clark expedition in 1804. This was just after Jefferson had negotiated the Louisiana Purchase from France, large territory which extended all the way up to Montana. Nothing was known about it, and so it was necessary to have an expedition that would go along the rivers and eventually end up in the Pacific Northwest.
There were less than 1,000 people living in St. Louis when Meriwether Lewis and William Clark started their westward journey. Yet only a few years after their return, St. Louis changed from frontier post to boomtown.
Soon you had entrepreneurs in St. Louis that became involved in all the aspects of the opening of the West, whether it be exploration or the various trade routes that existed. Particularly as soon as the Santa Fe Trail was opened in 1821, a lot of the material goods and the rewards from those goods made their way to St. Louis. And most people who went on the overland route outfitted in St. Louis.
After the Civil War, St. Louis would continue to build its fortune on trade and the Mississippi River. Yet as railroads gained prominence in moving goods and people, St. Louis's important riverfront district would begin a slow decline. By the time the Depression hit, the riverfront was home to one of the largest Hoovervilles in the country.
It once had been a bustling place when the steamboats were stopping there, and St. Louis was the center of river commerce for the entire American West. But now it was in bad shape.
The neglected and abandoned buildings were also of concern to St. Louis lawyer Luther Eli Smith.
Smith thought, why not destroy all these buildings, get rid of them, and turn this area into a real kind of garden spot. It wasn't a new idea. Other people had talked about it in the past, but Smith was the one who was well known enough in the right circles that he could start to really push this idea.
By 1935, Smith and St. Louis Mayor Bernard Dickman formed the Jefferson National Expansion Memorial Association to create a memorial park and a monument.
When Luther Ely Smith first pitched the idea about a memorial on the riverfront, they also wanted to weave in Thomas Jefferson. They felt that Jefferson was the person who really touched off American westward expansion, that he purchased the Louisiana Territory, that he championed the Lewis and Clark expedition.
Smith immediately went to work raising money for the memorial. He proved to be a shrewd fundraiser.
He got money from a particular lady, and it was a good chunk of change. And about a month later, he went back to her, asked for more money. And she said, hey, I just gave you money. He said, well, you need to protect your investment.
At the height of the Depression, Smith successfully lobbied the federal government to cover 3/4 of the estimated $30 million to build the memorial. The city of St. Louis approved a bond to cover the rest. Land acquisition for the memorial park began in 1937. But a lawsuit by 43 property owners stalled demolition.
It was a difficult road that Smith set for himself when he decided to make this riverfront memorial. First of all, because not everybody was exactly on his team, especially people who were landowners in the area. Their property was acquired through condemnation. Eventually, all the buildings in a 40 square block area of the city were torn down, flattened.
The landowners were bought out, and residents were forced to move elsewhere. Further delays occurred in 1942 with the outbreak of World War II. But as soon as it was over, Luther Eli Smith was back raising money, this time for a nationwide architectural competition.
And then he continued after World War II to keep the whole effort alive. It could have easily gone by the wayside at that point, and he personally raised the money to have a competition, which ultimately led to the arch design.
The competition would be one of the biggest architectural contests ever held in the United States. Designs would be submitted from all over the country. But a case of mistaken identity would keep the winning architect from knowing he was even in the running. The design for the St. Louis Arch was chosen during one of the biggest architectural competitions in American history. The contest was launched May 30th, 1947. It was open to any architect in the United States and offered prizes totaling $125,000.
This was the first big competition that was being held anywhere in the world after World War II, and it's the largest amount of money that had ever been offered in an American architectural competition up to that point in time.
By the September 1st deadline, 172 entries had been submitted. They ranged from the sublime to the bizarre. Among them, pyramids, a mini Niagara Falls, lighthouses, and a giant compass.
A number of the designs are a little weird. A lot of them looked a little bit like things from the World's Fairs of the 1930s. They're kind of streamlined and not at all like the arch in form. The arch really was pretty much unique among the entries in being such a bold design.
The judges pared the entries down to just 5 and invited the finalists to submit drawings for a second round of competition. Among those invited was entry number 144, a large stainless steel arch at the edge of a dense forest. From the Saarinen architectural firm in Bloomfield Hills, Michigan. Finnish architect Eliel Saarinen headed the firm, along with his son Eero.
Eliel Saarinen was well known around the United States. Eero Saarinen was his son and kind of in his shadow. So father and son both drew up plans for the competition, and they worked on opposite sides of the same wall. And the gentleman's agreement is they didn't look at each other's designs. So both were submitted at the same time in the first round of the competition.
The jury sent the winning notification off to Saarinen's home. Everyone assumed it was for Eliel, the father.
There was 3 days of celebration. And then they sent another envoy saying, "Oh, I'm terribly sorry, there's been a mistake. It wasn't Eliel that won, it was his son, Eero."
Eliel Saarinen's design never made it to the final round of competition.
And it wouldn't have been surprising in some ways if Eliel had won. He had done a lot of other major work at that time, but his work was more conservative. It was more like the work of the 1930s. And it was really quite a bold step for the jury to choose Eero's design. I think it kind of reflects this whole post-World War II sense that everything had changed and that all the ideas of the 1930s were really being put aside in favor of something new. And the arch is a very clear expression of that.
No other design came close to Eero Saarinen's stunning vision. He had found a way to create something entirely new by looking back into the past.
The basic idea was to create a very simple, clear geometric form. He looked at the presidential monuments in Washington, the Lincoln Memorial, simple rectangle, the Jefferson Memorial, a sphere. He first experimented actually with a dome shape for the monument, but then realized that that was probably too backward looking, too neoclassical, and then from there kind of moved to the idea of the arch.
Saarinen's striking catenary curve in a stainless steel sheath was his modern homage to the classical arch. It was also the perfect expression of a gateway.
He was just very careful and very meticulous and almost to the point of obsession in getting the angle just right so that we get the effect that we have today.
The judges of the architectural competition were delighted, but initial reaction from the public was mixed.
There were some people who just said, you know, it looks like a big croquet wicket, or, you know, they'll never be able to really build this thing. You know, there was a lot of question just about whether it could actually be done or not.
However, the most serious criticism came from a fellow architect.
In 1948, right after the design was announced, Gilmore Clark, who was an architect, a landscape architect in New York, charged that the design was basically a copy of a fascist design for a university and exposition that Mussolini had sponsored in 1942 outside of Rome.
Newspapers picked up the story and printed pictures of Saarinen's arch next to Mussolini's arch. The arches looked identical. Saarinen thought the charge preposterous. He had never heard of Mussolini's arch and stated that an arch, any arch, has no ideological connections. His biggest offender was the Jefferson National Expansion Memorial Association. It brought to light what most had overlooked. Mussolini's arch was never built, and it was different, shorter and wider. The association went on to endorse Saarinen's arch as, quote, a beautiful and inspiring form, perfect in its symbolism as a gateway to the West. The controversy soon died, and Saarinen quickly plunged into the work needed to make the arch a reality. But as design on the arch progressed, the Jefferson National Expansion Memorial lost its greatest champion, Luther Eli Smith. He died in 1951, but his dream lived on.
My father took over Jefferson National Expansion Memorial Association when my grandfather died, and all I heard around the house was the arch, and we have little arches everywhere. I mean, the big ones, little ones, plates. I think everybody was crazy about the design. It was really amazing.
By 1959, the last of federal funding was in place, and construction on the St. Louis Arch could finally begin. In 1961, however, Eero Saarinen was diagnosed with a brain tumor. He died soon after at the age of 51, never seeing the arch completed.
If Eero were to see the arch today, I think he would look at it dispassionately and wonder had he done everything just the way it ought to be done. And it's only now in retrospect, looking back, that we can see that in 1948, this very clear, elegant, engineeringly beautiful solution was absolutely perfect for its moment in time.
I think he was a great architect, a great sculptor, and sort of a Renaissance man. He was clever with form, but he was also clever with ideas, with concept. And that's a hard combination to find somebody that's like that.
Eero Saarinen and Luther Eli Smith, the two most important people responsible for the Gateway Arch, were now gone. But the arch still had to be built. Essentially, it would be two elongated towers, consisting of over 17,000 tons of steel and concrete. The towers would have to curve in the sky, meet in the middle, and not snap in high winds. It was chief designer John Dinkeloo who devised a way to anchor each leg. He suggested an orthotropic design, the first of its kind in the United States.
Orthotropic design that was used on the Gateway Arch basically does not involve a skeleton, a steel skeleton, the usual structure that you'd see a skyscraper. You know, first you see the steel skeleton rising, and then they put the elements on the outside of it, windows or the solid walls or whatever it is. And with the Gateway Arch, what you see is what's actually holding the structure up.
The exterior walls of stainless steel and interior walls of carbon steel with concrete pressed between them carry the structural load. This design allows the thrust to pass through the legs and be absorbed in the foundations. For the base of the legs, 300,000 feet of earth and rock were excavated. Footings 60 feet deep were sunk, 30 feet of that into limestone bedrock. Nearly 26,000 tons of concrete were poured into these footings.
It was quite an extensive concrete pour. I guess you could say it would be the same as like a 6-story building underground that's solid concrete that supports the legs of the arch and on each side.
To anchor the legs firmly to this base, The concrete was laid down in 4 11-foot layers, laced with networks of steel tensioning rods, 252 to a leg.
Buried into the actual foundations, the concrete structure, were pre-stressing rods, post-tensioning rods that would actually be extended as the arch was built. They'd keep adding to them. And those would go up the back of the leg on each side of the arch, almost like the tendons in your own leg. And those would hold the leg back and keep it as erect as possible as it was going up.
Construction of the St. Louis Arch could now begin. It would be a dangerous and unfamiliar task. Two major challenges were how to carry the tons of steel to the top and how to provide a work area for crew members without traditional scaffolding. The solution was the creation of a piece of construction equipment the world had never seen before. February 1963. With the massive foundations in place, construction on the arch itself could now begin.
Nothing like this had ever been done before. It was completely unique.
Construction workers faced frigid winter days and sweltering summer heat. But they would face dangers far more significant than those posed by the climate.
All construction is dangerous, but this particular project, since it was unique and no one working on it really had any experience of a similar kind of project, made it doubly dangerous.
In the days before strict safety laws, workers would be on steel beams with no support, hundreds of feet in the air or dangling in high winds.
I personally don't think that the arch could be built today because of OSHA restrictions and other things. I wonder whether it ever could soar to 630 feet the way that it did. You see men up there in the photographs and in the film where they're just hanging on, and sometimes the winds would get high during a storm or something, and just sort of clinging to the sides of this thing, you know, while it's shaking around. I mean, these guys, you see them up there, they didn't even have safety harnesses on or anything else.
The insurance company underwriting the project predicted that 13 people would die during the building of the arch. Nonetheless, construction proceeded. The basic building unit of the arch was the double-walled triangular section. It weighed over 50 tons and was hollow to allow room for a tram system. 142 of these building blocks would be needed to complete the arch. Each unit would consist of 6 stainless steel panels.
Those 6 panels of stainless were welded together into one side of the lower sections in the fabricating plants in Pennsylvania, and then they were joined with the interior surface.
The Pittsburgh Des Moines Steel Company, which had specialized in building bridges and elevator water towers, was responsible for the nearly 1,000 tons of polished stainless steel. The sections were transported by rail from steel mills in Pittsburgh. At the job site, the triangular wall sections were assembled on a concrete welding pad.
They would assemble them into the triangular shape, weld the corners, and then they were transferred by a railroad car, rebuilt railroad car, under the arch legs.
Lifting an arch section into place took only half an hour. They were connected to each other by high-strength steel tensioning rods and then welded together.
You would set it on top of the previously set section. These were then lowered down, and there were backup bars. By backup bars, I mean steel bars that were on the back side because you could only weld from one side.
The legs of the arch would be built simultaneously. Because the arch was to be so tall, one of the major problems was determining how to raise the steel sections into place. The first 6 sections of each leg, 72 feet, were handled with conventional cranes. Beyond that, it was necessary to use something completely different.
There were no cranes that were going to be able to lift pieces into place that were tall enough to get up above, 60, 100 feet. So they had to think of something, another way to do it.
The answer was the creeper derrick, specially designed for this project. Each of the 2 80-ton assemblies was essentially a tiltable platform mounted on railroad tracks. that were actually placed on sides of the legs. On top of each platform was a 130-foot crane.
The design for these creepers, where we had to change the elevation of the platform as the construction progressed, was a little different and required some very complete engineering to make sure that it would work in all situations on the arch.
The rigs climbed to predetermined stations, and the cranes then lifted the sections as well as the reinforcing steel and post-tensioning bars. As the derricks pulled themselves up the curved legs of the arch, adjustable supports kept them level regardless of the curvature of the legs. Rail was added every 48 feet, or after 4 sections were installed. Workers would then move the derrick up again.
As the work climbed higher and higher and the arch started to bend over, the platform had to keep going at more and more of an acute angle from the place where it was attached onto the tracks.
All of the methods of construction were, in a sense, first-time unique methods. The creeper derricks were part of that. The idea of putting a rail line up for the derricks to be able to climb up on the arch as it was being constructed was a very, very original idea.
Since the arch legs were being built at exactly the same time, sophisticated surveying was required. Measurements had to be very precise, since a slight deviation in any direction could result in the legs failing to meet perfectly at the top. To eliminate heat distortion caused by the sun's rays striking one side of the arch while the other side was in shadow, all measurements were done at night. Accuracy was achieved through triangulation. Engineers used 4 posts, or monuments, that formed a rectangle 300 by 720 feet, centered on the arch legs.
We established 4 monuments, 2 behind each leg of the arch, and measured the distance between those 2 monuments very accurately.
Surveyors employed an instrument called a theodolite, a device similar to a telescope that measures horizontal and vertical angles. Engineers used the 2 north monuments for triangulation on the south leg, and the 2 south monuments for triangulation on the north leg. And by applying the rules of trigonometry, the engineers could precisely determine any given point along the arch legs. Accuracy had to be maintained to a 64th of an inch. Thousands of tons of steel moved closer and closer to the arch's apex. But before Luther Smith's dream and Eero Saarinen's work of art could be completed, more technical challenges would have to be overcome. After 2.5 years of building St. Louis's Gateway Arch, construction was on schedule for an October 1965 completion date. As the 2 freestanding arch legs reached 530 feet, engineers faced the major concern that large construction loads and the weight of the derricks on top would bend the legs.
The legs were rocking and rolling up there. They were moving around. The wind was blowing everything, and you had the problem of the weight, and the weight was starting to make the legs start to topple inward. One of the big questions they had, as I understand it, is how do we keep these 2 sides stable until we can get the final section in and the weight can be released?
The solution was a 60-ton stabilizing truss, which would be installed horizontally between the 2 legs on June 17, 1965. This would be one of the most challenging tasks, as the 2 creeper derrick operators would meticulously work together to position the truss.
Any 2 crane lift is kind of a dangerous situation to start with. They have to keep it level, otherwise the load transfers to the other one. They tied a rope on each end of it, and the night before they marked it off in increments of 10 feet or so, so when the rope went through the pulleys that they had mounted on the ground, well, it was just like a measuring tape going up.
They had to do the most complicated lift of the whole project, where both creeper derrick operators had to be working in exact synchronicity with one another to pull this thing up. So you had a creeper derrick operator on the ground on the south side, one on the ground on the north side, both of them listening to commands of two guys with walkie-talkies at the top of the arch.
Okay, Bill, our big load's even with the top. All right, now, Bill, we're going to get on swing. We're going to get on swing. Hold that, Bill, hold that.
And they're both raising this huge, like 60-ton piece of steel that's almost as long as a football field, you know, and they're raising this thing, the two sides, slowly up into place, and they don't want to get one side too far ahead of the other, so when they get it to the top, they can lock it in.
After the stabilizing truss was in place, 21 additional triangular sections were added to each leg. The next step would be to put the final keystone section into place to complete the arch. The keystone section allows all the loads of the arch to transfer directly to the foundations.
It's all based on the classic concept that goes back to the Romans of an arch and the way that the weight of an arch is supported. And until a keystone is put in place to absorb the weight, and so the two sides push in on one another and hold each other up.
The St. Louis mayor wanted the last piece put in on a Saturday morning, but construction officials felt a greater sense of urgency to complete the job.
We had approximately 100 feet of stainless steel sticking above that. It's got an 80-ton derrick sitting on top of it. If we'd had a extremely tough windstorm or something like that, let's face it, it's 600 feet in the air. The arch is in a very vulnerable position.
The completion date was moved up 2 days to Thursday, October 28, 1965. Anticipation in St. Louis was running high.
For 2.5 years, people had watched this thing being built, you know, piece by piece and gradually rising above the horizon. Soon you have this beautiful, gigantic thing, you know, but everybody's question was, is it going to meet? There were even cartoons that existed at the time that showed that the two legs missed one another and they were kind of still building and going past, you know. So they showed it in schools, on television, closed-circuit TV, and all kinds of things, and there were a lot of people who took off work and were down waiting for this big moment, the joining of the two legs.
On a bright sunny day, as 10,000 people watched anxiously from the ground, the final piece was to be put in place. However, the sun on the south leg of the arch was causing it to expand.
The leg itself would start to warp, if you will, and so it would warp out of position. And once that happened, especially by the time you got up 630 feet into the air, there was no way you were going to be able to sort of skew it back into the right position. So what they did is they actually got the fire department, St. Louis Fire Department, to come out with their hoses and wash the leg with cold water up to quite a height, I'd say 200, 250 feet.
And the arch looked like Niagara Falls, really, with all the water coming down there.
The cold water tempered the expansion on the south leg, but the intense sun still caused the legs to lean to within 2.5 feet of each other. The keystone was 8.5 feet long. Fortunately, engineers had anticipated the problem and had hydraulic jacks that could apply 1 million pounds of thrust to widen the gap. That would allow the last section to be inserted. Ironically, the man performing that task, unlike the throng witnessing this event, would not actually see the keystone going into place.
I was probably was the only person in the whole country, or I don't know if we can say the world or not, but I was probably the only one that never seen it go into place, because the operator of the derricks were in a shack 100 foot behind the leg of the arch.
He had to listen to very specific commands that were given to him over like a walkie-talkie or telephone type of thing, intercom, which, you know, 2 inches to the right, 2 inches to the left type of thing to put the piece in place.
Vito was my phone operator, or really my eyes in the sky, so to speak. He was the man that directed the crane as to get up a little bit higher, or swing right, or swing left, or to boom up or down, whatever was needed.
As the crowd cheered, the final piece slipped evenly into place. The jack pressure was released. the natural thrust of the legs clamped the section into place, and it was welded together.
It was such an important date in St. Louis history is probably because people have been waiting so long for this thing to happen.
At no time during the construction of the arch did we ever, anyone that was closely associated with the project, did we ever feel that this thing would not meet at the top?
They built it up on each side symmetrically so that both halves of the arch went up at the same time. Incredible level of precision in the construction. It is amazing.
Now that the outside of the arch was completed, engineers turned to the next big project, installing a tram system that would take hundreds of thousands of visitors a year to the top of the curved arch and back. But how to design this unique system would stymie the top elevator experts in the world. The magnificent exterior of the St. Louis Arch was now complete. The next major task was building the unique tram system, one that would transport visitors up the tallest memorial in the United States.
Well, the unique challenges in developing this system, of course, were it's the level of precision which had to be followed in order to make it work, going up to 630 feet in a diminishing triangular space.
Then, an accidental meeting turned to good fortune.
It was just pure luck that a guy named Dick Bowser walked into the offices of Montgomery Elevator Company one day, just happenstance, came by to see a friend, and the friend had been talking with the Saarinen people, and the light bulb went off in his head, and he said, this guy's really inventive. He might be able to be the one that could solve the problem for them.
Dick Bowser was a college dropout. He and his father had developed and installed Bowser Parking System elevator equipment. The elevators traveled horizontally and vertically, as well as diagonally. Saarinen was familiar with the system and immediately hired Bowser in June of 1960. While Saarinen wholeheartedly endorsed Bowser, city officials questioned his background. Hoping to hire someone with more experience, they gave him an impossible deadline: deliver a proposal in 2 weeks.
I'll tell you the truth, that my reaction was, how much are they going to pay me for that 2 weeks?
The National Park Service, as the agency overseeing the arch, required 2 things: a passenger volume of 3,500 people in an 8-hour day, and a conveyance system that would not distort the exterior of the arch. Bowser first considered a standard elevator, but putting a square box in a curved arch was not practical. Bowser also thought about the escalator.
An escalator running at an angle in that curved arch, it just got too involved. And you'd had to change escalators every 20 or 30 feet up there.
He then considered the Ferris wheel as a possible model. The problem was the distance up one leg and down the other and back was over half a mile. Too unrealistic at that time for any chain or cable to travel.
It had to go on slowly, and it would never stop. It just had to keep going.
He started to get the idea that he had to have 2 independent systems, one for each leg.
Bowser finally came up with a solution combining the principle of the Ferris wheel with that of the elevator.
I thought about the barrels for people to ride inside of it, and then it was independently powered. Each one had a hoist machine and counterweights and everything, and it only took half of the arch sections.
The tram elements, the tracks and everything were put into place while the arch was being built, but then the cars had to be fabricated.
The idea for the car capsules came from a magazine ad.
And it was a new automobile at that time, a compact automobile called the Ford Falcon. and they actually had a little inset of how the seats were arranged in there. And he took that and actually used that as a kind of a model to show how a small space could accommodate several people, up to 5.
From this idea, he developed his final design. It was an 8-capsule train powered by an elevator mechanism. Inside are 5 seats. The capsules are similar to the barrels used in a cement mixer.
There's a pivot in the back of the capsule and the door on the front, and it's just open in there. And that's why it's like a cement mixer, because it has a pivot point, and then the outside is a ring with wheels on it.
The barrel can rotate within the frame that is supported by wheels running in the channel-shaped tracks.
When the train is in the lower load zone, it actually hangs below the track. And then as it goes up the arch, it gradually gets over to when it gets up the top, it's sitting on top of the track.
Even today, there is no other system like it in the world. Almost 1 million people a year ride the tram for spectacular views at the top. But few are aware of the risks it took to build the arch. Despite the insurance company's dire prediction that 13 people would perish during the construction, not one worker died.
I think that everybody on the project realized that safety was first and foremost on this job. We had an excellent safety record. At one time, we had over 500 working days without a lost time accident. I think we only had 3 lost time accidents during the entire project.
The arch may fill its millions of visitors with wonder, but it also fills its thousands of construction workers, engineers, and designers with a special pride.
Everybody that I've talked to that worked on the arch talks about it being one of the most phenomenal projects they ever worked on. And they say, you just can't imagine the reaction you get from people when you say you actually worked on the arch.
It's something that you can only do one time. It's a part of history.
I would say that it is one of the most extraordinary images in the 20th century construction, the most appropriate technical expression of our time.
Creative in design and aesthetic in appearance, the St. Louis Arch is a monument to those with a vision.